In this video, I'm going to show you how to factor a linear expression. One thing that we already know how to do with linear expressions is expand them. For example, here we've got 2 times the quantity a plus 3b, and we can expand out that expression by just multiplying the 2 to each of these terms. So 2 times a gives us 2a, and then plus 2 times 3b gives us 6b. Factoring is just the act of going the opposite way, starting with an expression like 2a plus 6b, and then pulling out a 2 here, say. So this is called factoring when we go backwards. The opposite of expanding, the opposite of distributing, is pulling out a common factor and then writing the expression as a product of 2 factors. That's why it's called factoring. It takes a single expression and writes it as product of 2 factors. One factor is 2 and the other factor is a plus 3b here. Here's another example. Expanding would be, say if we've got 3 times the quantity x minus 2y plus 3z, we expand that out by distributing that 3 to each of these terms. So 3x and then minus 3 times 2y, so minus 6y, and then plus 3 times 3z, so plus 9z, and then factoring would be going the opposite direction, starting with this expression 3x minus 6y plus 9z, pulling out a common factor to all those terms, which would be 3, and then writing that expression as the product of that common factor and the rest of the expression. So 2 factors are being multiplied together here, 3 and the quantity x minus 2y plus 3z. Alright, now let's do some factoring. Let's factor the expression 36a plus 12. So remember, in factoring, we want to pull out a common divisor of both of these terms. Actually, we want to pull out the greatest common divisor. So what is the greatest common divisor of 36a and 12? Remember, the greatest common divisor of these terms is the largest expression that will divide both of these terms with no remainder. So a won't be included in our greatest common divisor. We'll just have a constant. And so think, what is the greatest common divisor of 36 and 12? Well, we can pull out a 2, but we can do even better. We can pull out a 4, that'd be 36 divided by 4 is 9, 12 divided by 4 is 3, but we can still do better. Actually, we can go all the way up to 12. 36 divided by 12 has no remainder, it's just 3, and then 12 divided by 12, no remainder, that's just 1. So, okay, so let's write each of these terms again in terms of that greatest common divisor. So 36a will be 12 times 3a, and then 12 will just become 12 times 1. Now we can go ahead and factor out that 12. So we'll pull out a 12 and then write the rest in parentheses. And what stays in the parentheses is the other 2 factors, 3a and 1. So 12 times the quantity 3a plus 1. So there we go, we've got it. That's the factored expression. And we can also check that this is the correct factored expression by expanding it out. Remember, factoring is just the opposite of expanding. It doesn't change the expression at all, it just rewrites it a bit differently. So if we expand it out, then we should get back to the original form. So let's see what happens when we expand this out. If we distribute that 12 to the 3a and the plus 1, then we've got 12 times 3a and then plus 12 times 1. 12 times 3a is just 36a, and then 12 times 1 is just 12. And that matches up perfectly with what we had originally. So great. So we can be sure that is the correct factored form. Alright, here's another example. We want to factor this expression 12x plus 18y. And again, we can start that off by just finding the greatest common divisor. Neither of these terms has matching variables, so we don't have to worry about any variables in the greatest common divisor. So we can just look at the constants, 12 and 18. So what is the greatest common divisor of 12 and 18? What is the greatest expression that will divide both of these terms with no remainder? Well, 12 and 18 are both even, so we can divide them both by 2, but I think we can do even better. They're also divisible by 3, which means they're also divisible by 6, because if they're divisible by 2 and 3, then they're also divisible by 6. So 12 divided by 6 would be 2, 18 divided by 6 would be 3. It doesn't look like we're going to be able to do any better than that, so let's go ahead and write both of these in terms of that greatest common divisor, 6. So we've got 12x becomes 6 times 2x, and then 18y becomes 6 times 3y. And now we just go ahead and pull out the 6 outside some parentheses, and what goes in the parentheses are the 2 other factors from each term here, the 2x, and then the plus 3y, and now we have factored form. So there we go. Again, we can check this result just by expanding it out. It should match up with the original expression. So if we do 6, distribute it to the first term here, 6 times 2x, and then plus 6 times the next term, 3y, then that should match up. Let's go ahead and multiply it out. 6 times 2 is 12, so 12x, plus 6 times 3 is 18, so plus 18y, and hey, yeah, that matches up with what we had before, 12x plus 18y. Perfect. Here's our final example. We want to factor the expression 10a plus 25y minus 20z, and this is a bit intimidating because now we've got 3 terms. They've all got fairly large coefficients, they've all got variables, and there's a minus sign in there, so what do we do here? Well, it's really just the same idea. We just need to find the greatest common divisor of all these terms, and we'll factor that out. So what is the greatest divisor of 10a, 25y, and negative 20z? Well, you'll notice that none of the variables match up, so we don't have to worry about the variables at all, just the coefficients here, 10, 25, and negative 20. And to make life easier for us, let's forget about the negative also. Let's just think about just the plain old digits here, 10, 25, 20. So what is the greatest common divisor of 10, 25, and 20? Well, you'll notice that they're all multiples of 5. And so 10 divided by 5 would be 2, 25 divided by 5 would be 5, 20 divided by 5 would be 4, so 2, 5, and 4. It doesn't look like there's anything else that we'll be able to pull out, nothing really left to pull out. So let's just go ahead and write this in terms of the greatest common divisor, 5. And I don't think we're going to be able to pull out anything bigger than 5, because if we try to get bigger, say like to the next multiple of 5 to 10, then we can't pull that out of 25. So I think 5 is going to be the greatest common divisor here. So let's go ahead and write each of these terms using that greatest common divisor. So 10a can be written as 5 times 2a, and then 25 becomes 5 times 5, and then a y there also. So 5 times 5y, and then minus 20, we'll just keep that minus sign. So minus, and then 5 times what makes 20? Well, 5 times 4 makes 20, and then don't forget the z at the end there. And now we can go ahead and pull out that common divisor, 5, and that'll go outside some parentheses. Inside the parentheses would be the remaining parts of these 3 terms. So 2a, and then plus 5y, and then minus 4z. And there we go. That is our factored form. And again, we can double check it just by expanding it out and seeing if that matches up with the original expression. So if we expand it out, we distribute 5 times 2a, and then plus 5 times 5y, and then minus 5 times 4z, and we multiply that, we get 10a plus 25y minus 20z, and hey, that matches up perfectly with what we had originally, so we can be sure that our factored form is correct. In these examples, we focused on expressions where all the factors were separate. In the future, though, we'll also learn how to factor expressions which have mixed terms consisting of more than one variable together.